Alright, here's our chance to learn a little more about these second order linear ordinary differential equations. And what makes them linear? I haven't talked about that yet, but they're linear with respect to the derivatives. Like there's y double prime, and there's y prime. Neither of them are squared or have any other operation upon them except for perhaps some coefficient. Alright, so that's what makes it linear. It's obvious what makes it second order because there's the second order derivative, and it's homogeneous because of the zero. What's different about this one than the ones I've talked about already is, let's say that the coefficients are not constant. Alright, so p of t is some function of t, q of t is some function of t. You know, here in this one we're say that t is the independent variable, and ultimately we think that there's some function of t that's a solution to that. Okay? Alright, now there's something everybody who works with these needs to be aware of, and it's the principle of superposition. Here's what it says. Say you had that, whatever form it takes exactly, and I have two functions of t that are solutions. Whether you found them somehow, whether you by trial and error found y of t and it happened to work up there, just say they're solutions. Doesn't really matter how you get it. It's always true that this linear combination of those two solutions will also be a solution. You know, take whatever constants c1 and c2 you want. I promise you that that's also going to be a solution. Okay? Alright, now, example. So here's an example of something like that. Alright? You might say, well, it didn't say you could have a function of t right there. Well, then you can divide it out if you really want to. In fact, let's say, maybe put a little bit restriction on here that would allow us to do that. Okay. So anyway, say you've got that. Let's verify that these work. Okay? In other words, do these really work up there in that the way that it is? Well, there's only, for us, since say we don't know how to solve that yet, there's one way to find out. So let's take this one and work with it and see if it actually is an answer to that. What's a y1 prime of t? It's going to be 2t. And y1 double prime t, it's just going to be 2. And what's that differential equation look like? Assuming that we investigate whether that's really a solution or not. It says t squared y double prime. That's going to be t squared times what turns out to be 2 minus 2y, y being t squared. You know, y being the dependent variable, which at least for that function is t squared. So we'll do like this. Well, that's about as obvious as a solution's going to be. 2t squared minus 2t squared is in fact equal to 0. So that one's verified. Well, this one wouldn't be too much different, but let's work it out over here. So y2 prime, it's going to be negative 1 over t squared. And we need the double prime, y2 double prime. 2 over t to the third power. It's so much different than that one. Can it work also up there? Let's see. So the differential equation in the case of that being a solution takes this form. T squared times 2 over t to the third power. Alright. Minus 2 times y. So that'll be 2 times, what was our dependent variable in the case of that assumed solution? Is 1 over t. And is that equal to 0? Well, this is 2 over t, and that's also 2 over t, so it also works. Okay. Now, let's just say that you had that. Alright? Let's just say that, as we verified right now, that both of those functions that take a totally different form, that they're both an answer to that. All I'm saying is that it so happens to be true that this would be a third one. Here's a third solution to that. Say you had 3t squared. I take some constant times that one. Minus 4 times t to the minus 1. Some other constant times this one. That's also a solution. You can check it, just like we checked these. Try it out. Take the second derivative, take the function as it is, and put it in there, and I guarantee that it'll work. Alright, how do I know? Well, the principle of superposition says that will happen.